Pranav is working in Maharashtra State Electricity as an assistant engineer. He is going to the inspection of the towers in those areas. Signals among 8 towers P, Q, R, S, T, U, V and W are transmitted in the following manner. P, Q, R, S, T, U, V and W are arranged in a straight line facing north but not necessarily in the same order. Q is placed third to the left of T, V is placed fifth to the right of Q, but neither is placed at any of the extreme ends. Two-way transmission is possible between P and Q, Q and S, S and U, R and P, T and R, T and V. U does not arrange at an extreme end. One-way transmission is possible from R to Q, S to T, V to U. R and S towers are immediate neighbors of each other, but neither of them is an immediate neighbor of tower V. Only one tower is placed between R and P who is not an immediate neighbor of T. Right? So basically he's talking about 8 towers which are arranged in a straight line. Right? He says P, Q, R, S, T, U, V and W are arranged in a straight line facing north, but not necessarily in the same order. So let's first work on the arrangement, and after that we'll look at what exactly this two-way transmission and one-way transmission means, right? Two-way and one-way transmission. So let's first arrange them in the straight line. All of them are arranged in a straight line facing north, right? So look at the first point. Q is placed third to the left of T. Q is placed third to the left of T. So let's assume this is T. Q is placed third to the left of T. Left of T is our left. So first, second, third. Q is placed here. Why are we saying left of T is our left? Because all these towers are facing north, right? So when you're facing north, when a person is facing north, left is towards left and right is towards left. Left is towards our left and right is towards our right. Okay. So Q is placed third to the left of T. Then next point, V is placed fifth to the right of Q. V is placed fifth to the right of Q. V is placed fifth to the right of Q means what? See, right of Q is towards our right. So fifth to the right of Q. First, second, third, fourth and fifth. This is V. Yes or no? V. V is placed fifth to the right of Q. So first, second, third, fourth, fifth. But neither is placed at any of the extreme ends. Now this is a very important point. He says V is placed fifth to the right of Q, but neither of them are placed at any of the extreme ends. See, if you look at it, we have already got 6 positions here. 1, 2, 3, 4, 5, 6. Of course, only 3 of these 6 positions are filled, but we know the 6 definite placements, right? 1, 2, 3, 4, 5, 6. And we also know that neither Q nor V are at the extreme ends, right? Neither Q nor V are at the extreme ends, right? But neither is placed at any of the extreme ends. So Q is not the extreme end, V also is not the extreme end, which means there should be at least one tower before Q and one tower after V. Yes or no? For these two to not be the extreme ends, there should be one tower before Q and one tower after V. And that gives us the 8 positions. 1, 2, 3, 4, 5, 6, 7, 8. You understand? See, the point is whenever you are doing a straight line arrangement, a linear arrangement, the definite positions are important. So with the help of that data given so far, we have been able to find that the definite position of Q is second from left. Definite position of T is 5th from left and definite position of V is 7th from left, right? So we know that these are the 8 numbers 1, 2, 3, 4, 5, 6, 7, 8 in which 2nd, 5th and 7th positions are Q, T and V respectively. Okay. Then next he talks about this two-way transmission. He says two-way transmission is possible between PQ, QS, SU, RP, TR, TV. We'll look at that later. We'll not do it immediately because we got to know what are the exact positions first of all, right? So let's leave that point aside. Go to the next one. U does not arrange at an extreme end. U does not arrange at an extreme end. What does it mean? You will not take the extreme position, which means you will not come in this position and in this position. You cannot come in the extreme positions. Then he talks about one-way transmission. One-way transmission is possible from R to Q, S to T, V to U. Again, this also is not very useful immediately. So let's skip it and move to the next point. R and S towers are immediate neighbors of each other. R and S towers are immediately neighbors. I think it should be immediate, not immediately, right? R and S towers are immediate neighbors of each other. So R and S are immediate neighbors of each other. Now try to understand. For R and S to be immediate neighbors, they should be in 2 consecutive positions. R and S both have to be in 2 consecutive positions, right? So the only pair of consecutive positions available here is this. Yes or no? All the other positions will be alternate. Alternate as in not consecutive, right? R and S have to be consecutive neighbors, immediate neighbors. So they have to sit in two consecutive positions. So the only possibility is R and S both come here. Again, what order we don't know. It can be RS or SR. You're able to follow. They are immediate neighbors does not mean that R comes first followed by S. It can be R, S or SR. But then yes, R and S will come here. So we'll put that in brackets like this. It can be RS or SR. Next point. R and S are immediate neighbors of each other, but neither of them is an immediate neighbor of tower V. This is redundant in my view. If you actually look at it, this point given here is redundant. But neither of them is a neighbor of tower V is useless. Because we have already found that R and S are not the neighbors of tower V. You getting it? So this statement or this part of the statement is anyway useless, right? We don't even need that. Next point. What's the next point? Sorry. Only one tower is placed between R and P. Only one tower is placed between R and P, who is not an immediate neighbor of T. So let's try this. Only one tower is placed between R and P, who is not an immediate neighbor of T. See, we know that there are two possible positions for R. R comes here, followed by S here, or S comes here, followed by R here. So R can take any of these two positions, right? If we take this as the correct position of R, what happens? He says only one tower is placed between R and P. Only one tower should come between R and P. So if R is here, then definitely P would come here. Yes or no? Only one tower between R and P. See, P cannot come here because it is already occupied by T. But there are possibilities if you say S and R here. In that case, what happens? If we take S and R in this manner, then see, this is already occupied by Q, we know. And we know that there is only one tower between R and P. So according to that, P has to come here. One tower between R and P, which is T. You getting it? RS or SR. These are the two cases. If you take R followed by S, P has to come here. If you take S followed by R, then P has to come here because there should be only one tower between R and P. So P cannot come on the left side. It has to come on the right side. But if you take P on the right side, what happens? P and T become neighbors of each other. See, the point he says is P is not an immediate neighbor of T. Here P has become an immediate neighbor of T, which means this is wrong. The first case itself is correct. R followed by S. So we can now conclude that R comes in the first position followed by S in the next position. Right? So we can clear this. It is like this. Right? R here and S here. And of course, P takes this position because only one tower is there between R and P. Now, so this point is done. Only one tower is placed between R and P, who is not an immediate neighbor of T. What else is left? So P, Q, R, S are done. T and V are done, right? So if you see P, Q, R, S, T and V are arranged. Only U and W are left. See, we know that U cannot come in this position. So if U cannot come in this position, the only possibility is this. And then if U is placed, the only tower left is W, which has to take this position. So we are done. I think the arrangement is P, Q, R, S, T, U, V, W. So it is actually in the alphabetical order, right? P, Q, R, S, T, U, V, W. So the towers are arranged in alphabetical order, right? Towers are arranged in alphabetical order. Let me just rewrite this, right? P, Q, R, S, T, U, V, and W. So we have got the arrangement. Now let's look at that two-way, one-way transmission, right? P, Q, R, S, T, U, V, W. Now look at this point, right? Two-way transmission. What is it? What is given here? Two-way transmission is possible between PQ, QS, SU, RP, TR and TV. So two-way transmission basically means here that P can transmit signals to Q and Q can also transmit signals to P. Right? So two-way transmission is possible between P and Q. Means what? P can give signals to Q and Q can give signals to P. Right? So P to Q is possible, Q to P is also possible. So I am putting a double-headed arrow. You know, double-headed arrow means what? You can go from P to Q and also come from Q to P. Both are possible. So P and Q, Q and S, between Q and S also it's possible. So Q and S, between Q and S, two-way transmission is possible, right? So Q to S and S to Q, both are possible. Then S and U, S to U also it's possible, right? S to U and U to S. Then R and P, R and P means what? This way, R to P and P to R, right? And T and R, yeah, again, T and R is this. T to R signals can be transmitted and R to T also it can be transmitted, right? And T and V means what? This way. T to V and V to T, both are possible. So everything on top is a double-headed arrow, right? All these are double-headed arrows. So two-way transmissions are possible, right? We have taken all the possible pairs that were given here. PQ, so P to Q, Q to P, QS, Q to S and S to Q, SU, S to U and U to S, R and P, R to P and P to R. Then T and R, T to R, R to T, and T and V, T to V and V to T. Now look at the next point here, one-way transmission. Something was given about one-way transmission, right? One-way transmission is possible from R to Q, S to T, and V to U. So there are only 3 one-way transmissions possible, right? We will take the one-way transmissions at the bottom, so that's easy to distinguish. R to Q, R to Q. Remember, one-way transmission, R to Q. So you can go from R to Q, but you cannot go from Q to R, right? Q to R transmission is not possible. R to Q is possible. So R to Q, then S to T, S to T. From S you can go to T, S to T, right? S to T. You cannot go from T to S, but you can go from S to T directly, right? And V to U, and V to U, V to U. V to U is also possible. So that's the difference between one-way and two-way transmission. You're able to follow. Two-way means both the towers can connect with each other. One-way means only one-sided. So one-way transmissions are R to Q. R can give signal to Q, but Q cannot directly give signal to R. Indirectly they can give signals, but directly only R can transmit to Q. Q cannot transmit to R. Similarly, S to T. S can transmit signals to T, but T directly cannot transmit signals to R, S. And V to U. V can transmit signals to U, but not the other way around, right? U cannot transmit signals to V. So all the arrows on top are double-headed. So very clearly those are two-way communications, and those at the bottom are single-headed. Now let's look at the questions. So the first one here, see what it says. For which of the following pairs of towers signals can be transmitted between them in both ways? That is, either from the first tower to the second tower and from second tower to the first tower, such that in each case the signals passes through all the other towers exactly once, not one, exactly once. I think there's some spelling errors here. It should be exactly once, right? Exactly once. So read the question again. What does it say? For which of the following pairs? So some pairs have been given to us: VP, PQ, VU, and UP. So for which of the following pairs of towers signals can be transmitted between them? Signals can be transmitted between them in both the ways. That means from first tower to second tower, and from second tower to the first tower. So from V to P and from P to V, such that in each case the signals passes through all other towers exactly once. So when you are transmitting signal from V to P, the signal should pass through all the other towers, all the remaining 6 towers exactly once. Exactly once. It should not be more than once. It should be exactly once. So let's find out. I think let's take option by option and verify, right? Let's just go options by options. Okay. But the problem here is the tower W is not connected at all, right? I mean, if I just look at the diagram, W is not connected to any of the towers. So Ratna has to clarify. What do we do with W? I think answer should be none. In fact, straight away we can say answer is none of this. Why is answer none of this? See, because the question says the signals has to pass through all other towers exactly once. But if I look at the communication here, the communication is only between the first 7 towers. This 8th tower W is not connected at all. W cannot communicate with any of the remaining towers. So even if I say V to P, you may be able to connect V to P, but V is not connected to W at all, right? So I think something is wrong here. Either the data given is incorrect because W is not connected, something is missing there, or the question, of course, the options are wrong, right? Let's see. I mean, just forget about W for a moment. Let's forget about W, right? Let's keep W out of picture. But strictly speaking, answer should be none of this, because I'm just trying to keep W outside and then verify the answer so that you know how to solve such questions, right? So what exactly does it mean? It says that there should be a communication from V to P in such a way that the signals passes through all the other towers. Let's try that. See, V to P. So how do I go? I can go from V to U, then U to S. See, just try to trace the path, right? And make sure that you can go from V to U, but you cannot go from U to V like this, right? So I'm just trying to follow the direction of arrows. So from V to P. So V to U, just look at this pointer. V to U, U to S, S to T, T to R, R to Q, and Q to P. So V to P is communicated, right? Let me use my only concern is if I use a highlighter, then it will become too messy, but let me just show it to you, right? I'll just show with one example. You can try the other ones. Okay. Let's see the communication from V to P. How does it happen? V to U, U to S, S to T, then T to R, R to Q, and Q to P. So if you see, the signal has passed through each tower exactly once. V to U once, then U to S, so passes through S once, then passes through T like this once, then comes to R, then U, and then P. Right? No way the signal has passed through the same tower twice. You getting it? If you see, it has not passed through the same tower twice. So V to P is possible. And then we have to check P to V also, because he says between them in both ways, from first tower to second tower and from second tower to first tower. So V to P is done. Let's check P to V now. I'll use a different color. Let's use maybe this color. Right? So from P to V now. P to V. P to V. P to Q. But if I go from, see, the problem is this. If I go from P to Q, then I cannot go to R. I have to go to S. So P to Q, Q to S, S to, no, S to U will not help. S to T, T to R, R to Q will, again communication will happen twice. You understand? P to Q, Q to S, S to U, but then I cannot go to V. If I take S to T, I'll have to come back to R, and from R I'll have to either go back to P or have to go to Q, which means I will be crossing the same tower twice. So P to Q is not the choice. I think P to R, let's say P to R, R to Q, Q to S, Q to S, S to T, T to R again will be twice, right? P to R, R to Q, Q to S, no. So P to R, R to T. I cannot go to V because the moment I reach V, the signal is closed, right? So P to R, R to P to R, R to maybe T. No. P to R, R to Q, Q to S. Are we able to go from P to V? I don't see a straight connection from P to V, right? I mean, we have got from V to P, but is there a connection from P to V? Let me write it down instead. P to V. So I can go from P to Q. From Q I have two choices. No, from Q I have only one choice, sorry. P to Q, let's say if I go, or let me do it this way, no? From P there are two choices. Either I can go to Q or I go to R. So P, then I go to Q or I go to R, right? See, P to Q is possible, P to R is possible. Then from Q, the only choice is Q to S, because Q to R is not connected the other way. So Q to S, right? Q to S. But from S there are two choices. Either I go to V, or either I go to U or I go to T. So U or I go to T, right? S to U or S to T. From U, at U I end. See, after U I cannot proceed because U has no outgoing signal. You're able to follow? U does not have an outgoing signal at all. U has only inputs. Yes or no? You can only take signals. You cannot give signals. And the fact that you cannot give signals, from U I will not be able to reach V. So that path is closed. Try the other path. P to Q, Q to S, Q to S, yes. Then S to T. Then at T what happens? The outgoing is possible only from T to V I can go, or T to R. So T to V or T to R. But if I go to V, I have reached, I have closed the path, right? We have to go from P to V. So P, Q, S, T, V. But in this case, R has not come. See, he says it should pass through all the other towers. So R has not come into the picture, right? So this also is wrong. While we have reached P, we have not crossed all the other towers. Right? Signal passes through all other towers exactly once. R has not come into picture here. Then try this path, P to Q, Q to S, Q to S, yes. Then S to T, S to T, from T to R. And from R, the outgoing is either possible, I mean, there are two possible outgoings, either go to P or go to Q, but no point in going back to P, right? So let's take only Q. There are two possibilities, but we will not take the other one. See, if you go to P, you go wrong because you're going back to P. We have to go to Q. But when I go to Q, again, outgoing is either at P, which makes no sense, or at S. So either I go to P, which will be wrong, or I go to S. See, why is P wrong? Because we started with P and we are going back to P. So that's not possible. If I go to S also, it's wrong because you see S has already come twice in this picture. P, Q, S, T, R, Q, S. S has come twice. So this also is wrong. So it means all the paths are closed. From P, all the paths are closed like this. If I take via Q. So let's go via R. So from P, if I go to R, P, I will go to R. From R, the outgoing is possible either to T or to Q. So either we can go to T or we can go to Q. You know, R to T or R to Q. Let me take only the possible cases now because there is a space crunch. From T, I can go to, from T, the outgoing is possible only to V. From T, the outgoing is possible only to V. Yes or no? So from P, either I can go to, no, outgoing is possible two ways. Either I go to, see, from T, I can go back to R, but that will be wrong. Or I can go to V. Even this will be wrong because we have not passed through all the towers. Then let's take the last option, right? From P, you go to R. From R, you go to Q. From Q, let's say you go to S. From Q, you go to S. From S, you can either go to U or you can go to T. So either go to U or go to T. From U, outgoing is not possible. So this is closed, right? If you go to T, from T, you can either go back to R, which will be wrong. From T, you can either go back to R, which will be wrong because R will come twice, or you can go to V. But even if you go to V here, see, P, R, Q, S, T, V have come, but U has not come into pictures. This also is wrong. Yes or no? P, R, Q, S, T, V, U. See, from V we can go to U, but the question says that the signal should be transmitted between them such that in each case the signal pass through all the towers exactly once. So when we are transmitting between V and P or P and V, the other tower should come in between them. Pass through, signal should pass through the other towers, exactly once, right? After V, if I go to U, like for example, if I go to U now, it is wrong because I was supposed to pass the signal from P to V. And in that process, I should cross through the other towers exactly once. Here, U is coming after V, which makes no sense in my view. So I think first option itself is wrong, right? First option itself is, and overall, the options are wrong here because we know that W has not come into picture at all. So Ratna should clarify if something is missing in the data or, right? I don't think we'll be able to go back from P to V. Anyway, so I think that's how you deal with such questions, right? So get the arrangement. Arrangement was simple. P, Q, R, S, T, U, V, W is what we got. But answer for the first one should be none of this, right? Let's look at the second question. There's one more question with this. I'll write down the order first. The advantage is it was alphabetical order, right? So easy to remember. P, Q, oh, I've cleared the transmissions. Sorry. P, Q, R, S, T, U, V, W. I'll quickly mark the two-way and one-way transmission. Two-way transmission is between PQ, QS, SU, RP, R and P, RP, TR, T and R, and T and V. Okay. And one-way transmission. Okay, let me just check. PQ, QS, two-way transmission. SU is there. RP is there. Yes. TR, T and R, T and V. And one-way transmission is from R to Q. From R to Q, S to T, and R to Q, S to T, and V to U. R, Q, S, T, and V, U. Okay, so what's this question? How many different routes can the signal be transmitted from S to R and R to S, passing through other tower exactly once? Okay, so we have to, again here also you will find that W is anyway not connected. So for this question also we can say, answer is none, because actually W is not in the picture, right? How many different routes can the signal be transmitted from S to R and R to S, passing through other towers exactly once? But here he has not mentioned all the other towers, so maybe we can consider some of the other towers, right? He has not mentioned all other towers, right? He has just mentioned that passing to the other towers exactly once, right? Passing to the other towers exactly once. In the previous question, I guess he had mentioned all other towers, right? Yeah, see, all other towers. Here he mentioned the word all. In this question, if you see all other towers, but next question he just mentioned other towers. So maybe we can just consider some of the towers, right? So we have to pass the signals from S to R and R to S. So we have to consider both of them separately. So S to R, let's try out S to R. So how can we go from S to R? I think SU will not help. ST and then T to R. Yeah, so number one is S to T, T to R, right? See, S to T, T to R. That's one way of doing it. Number two is what? S2. So I can go from S to T, that we have already considered, and then from T to R. That's one way of doing it. Then S to T, maybe T to V, V to U, S T, T V, V U. But from U again going back to S is not allowed, because we have to pass through the towers exactly once. So that's the only way from S to R. From R to S. No, let's try the other way, right? S to U. S to T is done. S via U. S to U. S to U also will not give us any results, because the moment you reach from S to U, then the only way, you will get stuck at U, because U cannot pass signals to any other tower except S. So that's done. With respect to S, it is done. Let's try R to S now. R to S. So I think R to T, T to V, and U to S. Yeah. So R followed by T, followed by R, followed by T, followed by V, followed by U, followed by S. That's one way of doing it. Then what else? Maybe R followed by T. From T we have considered V, but yeah, this is one way. But from V, U is the only possibility, and from U, S. So that's done. Now let's consider the other possibilities. From R, the other way, where else can we pass the signal? We have considered T. Let's consider P now. R to P, P to Q, Q to S. R to P, P to Q, Q to S. You see, R to P, P to Q, Q to S. Or R to P, P to Q. That's it. Any other possibility? R to P, P to Q, Q to S. R to P. From P I can only go to either Q or R. So R to P, P to Q, and from P I can only go to S. So I think there are only three ways, right? R to Q also I can go. R to from R there are three outputs. So R to T we have considered, R to P we have considered. Now let's consider R to Q. I think we can go from R to Q, and Q to S. Or R to Q, Q to S is done. R to Q, Q to P, P to R is not allowed, P to Q is not allowed. Yeah. So I think I'm getting four ways. These are the four ways of doing it, right? Option 4 will be the answer. Alright, option 4. Let me just come back to the video screen. So I think interesting one. Two-way transmission, one-way transmission between different towers. Of course, there's some confusion with respect to tower W there, right? No connection of tower W with any of the remaining 7 towers. But for us to just try out the questions, we have considered that W is not in the picture. Let's say there are only 7 transmissions, 7 towers. So that way, if you see, we had to connect S to R to S. We found 4 different channels, 4 different ways of doing it. And then in the previous question, of course, he had mentioned all the towers. So if it is all the towers, W is also a part of all the towers, and then answer straight away will be none of this. But keeping W aside, I think we got, even then we were not able to crack it actually. We were able to go from one tower to the other tower, but not return back. So yeah, interesting, but I have not seen such questions in bank exams so far. I don't know from where it has been chosen. Only Ratna can tell us, but good one. Shiti says, I'm getting 5 connections. So what is the 5th connection? Oh, Shiti has got 5 connections. Hold on. Did we miss something? RQS, yes, we have considered. STR, yes, we have considered. SQPR, S2Q, Q2P, P to R. Oh, yeah. SQ, QP, and PR. We missed that. Sorry. Let me share the screen and show it to you. Good that I did not clear the. Yeah. So as rightly pointed out, answer will not be 4. Actually, sorry about that. There is a 5th way of doing it. Right. From S, we can go to Q. From Q we can go to P, and from P we can come back to R. See, S to Q, Q to P, and P to R. Yeah, so this is the 5th way of doing it. Thanks for pointing it out. 4 was the wrong answer. Sorry about this. Answer should be option 3. 5 ways. Maybe again if you find one more way it can be 6 also, but I think 5 is the answer, right? There won't be a 5th way there. Or there won't be a 6th way, or is there a 6th way? Let me just check. No, I think 5 is the answer. Alright, option 3, 5.